All right, so to find the domain of these equations, so for number 1, 11x minus 1, you notice, so the domain is all valid x's. So you look at this equation and you see that if x is 0, I can multiply 0 times 11 and then subtract 1. So 0 can be in the domain. If x is 2, I can do it. If x is negative 10, I can do it. So basically, no matter what x is, positive or negative, it can be multiplied by 11 and then subtract 1. So that's why we say that the domain is all real numbers. There is no restriction on what x can be. Or we can write it in interval notation, negative infinity to infinity. For the second one, you have square root of 3x minus 2. I think it's like this, plus 1 over x. So basically, the domain for this one is all valid x's. So if you look at this portion right here, x is a denominator. So from that, you get that x cannot be equal to 0 because we can divide by 0. So x cannot be 0. And then, wait, I don't know if you meant, I think you meant this 3x minus 2 plus 1 over x maybe? Anyway, so if it's like this, x cannot be 0 because we can't divide by 0. And then since 3x minus 2 is underneath the square root, we can't have square root of a negative number. Okay, that's not a real function. So we must say that whatever is underneath the square root has to be positive or 0. So it's greater than or equal to 0. So then to solve this, I add 2 to both sides, so I get that 3x is greater than or equal to 2. And then I divide by 3, and I get that x is greater than or equal to 2/3. So now, the domain of the resulting function is x cannot be 0, and x is greater than or equal to 2/3. Okay, so if you draw the number line, let's say 0 is here and then 2/3 is there, basically x cannot be 0 and it has to be greater than or equal to 2/3. So it's greater than or equal to 2/3. So these have to take place at the same time. So the domain has to be 2/3 to infinity, because infinity is here. Because it can't be something between 0 and 2/3, because that's not greater than 2/3. Okay? It has to be greater than 2/3 so that the quantity underneath the square root stays positive. And then square root of 1 over x plus 2. So if this is what you want, 1 over x plus 2. So basically, we have two rules in here. Since x plus 2 is a denominator, so it can't be 0. So I must have that x plus 2 does not equal 0, because I cannot divide by 0. So that means that x cannot equal negative 2. So this is my first thing, x cannot equal negative 2. But then at the same time, this whole thing is underneath the square root. So the whole fraction cannot be negative, because I can't have square root of a negative number as a function. So then I know that 1 is positive, so that means that x plus 2 has to be positive as well. So x has to be greater than negative 2. So then if you look at these, so x cannot, negative 2 is here, so it cannot equal to negative 2, and it has to be greater than negative 2. So it's basically is this side of it. So the domain is negative 2 to infinity. So it can be anything less than negative 2. For example, if you have negative 5, then you would have square root of 1 over negative 5 plus 2, which is square root of negative 1/3, but this is not possible in the real number system. This is a complex number. All right, so basically to find the domain, if you have a fraction, you got to make sure that the denominator is not 0, and if you have a square root, you got to make sure that the quantity underneath the square root is not negative. Okay, so now let's look at a system of 3 equations and solving it. So if you have, for example, x plus 3y plus z equals 10, and then x minus 2y minus z equals negative 6, and then the third one, 2x plus y plus 2z equals 10. So this is your system. So basically you got to write the matrix first. So the matrix is just going to be the coefficients of the x, y's, and z. So in the first one, you're going to put 1 for the coefficient of x, 3 the coefficient of y, and then 1 for the coefficient in z. And then 1 for the coefficient of x here, negative 2 for the coefficient of y, and then negative 1. And then for the last row, you have 2, 1, 2, 2, 1, 2. And then you attach this column, 10, negative 6, and 10. So this is going to be your augmented matrix. So this is the one that you got to work things out so that it has all ones on the diagonal and zeros before below each diagonal one. So I'll show you in a second. Okay, so notice that the first diagonal one is already a 1, so we don't have to make this one a 1. If this was a 2, you would divide the whole row by 2 to get a 1, but this is already a 1. So your next step is to make here 0. So I want to make this one a 0, and I want to make that one a 0. So how can I do this? I can so we're going to keep the first row, 1, 3, 1, and then 10. And then I want to make this one a 0. So I can take row 1 and subtract row 2. Or I can take negative 1. Let's do this. I can take negative 1 times row 1 plus row 2. And that's going to be my new row 2. So these are legitimate operations that I can do to a matrix. I can multiply everything by negative 1. I can add 2 rows. Okay? So negative 1 times row 1 plus row 2. And so in the second row, this is what I'm going to put. So negative 1 times 1 is going to be negative 1, and then plus row 2. So it's going to be negative 1 plus 1, which is 0. And then negative 1 times 3 is negative 3. Negative 3 plus negative 2 is negative 5. Now negative 1 times this is negative 1 plus row 2. So negative 1 plus negative 1 is negative 2. And then you do it to the column, to this as well. So negative 1 times 10 is negative 10 plus negative 6, negative 16. Now, how can I make a 0 instead of a 2 in here? So I can take negative 2 times row 1, because that will give me a negative 2 in here, and then add it to row 3. So that's exactly what I'm going to do. I'm going to take negative 2 times row 1, and then add it to row 3, and that's going to become my new row 3. Okay, so let's look at it. Negative 2 times 1 is negative 2, plus 2 is 0. Now negative 2 times 3 is negative 6, and negative 6 plus 1 is negative 5. Next, negative 2 times 1 is negative 2, plus 2 is 0. And for the last one, negative 2 times 10 is negative 20 plus 10 from here. Negative 20 plus 10 is negative 10. Okay, so I made zeros.